for the next presentation, I would like to call upon stage our esteemed speaker, Guillaume de Vertemont. I hope I managed to pronounce it the way you said it. Thank you so much for joining us today. He's the Global Market Director for Automotive, Aeronauticas and Space Air Liquide. The topic of the presentation is the role and influence of industrial gases on battery performances. The stage is all yours, sir. Thank you so much.
Thank you very much. So hello everybody. So today I'm going to speak about the industrial gases and about their role on the whole value chain. Just a few words about Air Liquide at the beginning. So Air Liquide, we are a global company, a French company, and actually we separate the components of the air to take advantage of their properties. So what does that mean? That means that our raw material is available everywhere for free and sustainable. One thing also just regarding the ways of supplies. So we have two ways of supply. Either liquid gases are stored in a tank at the premises, which requires some transportation and of course some CO2 emissions. Either we have what we call on-site products. That means that we supply the gas, we produce the gas directly at the plants. So what is a role in the battery ecosystem? So first, from the beginning, Air Liquide has made a strong commitment, strong engagement regarding the battery ecosystem. We really wish to contribute to the EV transition, and this is why from the beginning we have been members of all the global leading associations, NatBat in the US, KBI in Korea, Upsell in Europe. We have more than 100 customers in the battery ecosystem, and apart from industrial gases, we also work for the advanced materials. It's an experience that we inherited from the semiconductor. And what is it about? Mostly about thin coatings for interfaces, and especially atomic layer depositions. We also supply the distribution system from critical fluids that are required especially for electrolytes and solvents. So now you will tell me, okay, fine, but what is the role of the gas within the battery value chain? So industrial gases are required at all steps of the whole value chain, from the mining and refining phase, where it is used mostly for purification and crystallization, but also during the active material phase for the anode, the cathode, and the electrolyte, through the cell production, and finally for the recycling phase. So IG's industrial gases are necessary. They represent a very tiny cost, very finite cost for the battery stack. However, they are essential for the process. So if we go through just quickly, going through the different usage for the graphite production, gas is mostly used for inerting. Nitrogen is used for inerting, preventing the oxidation by removing the oxygen, but also avoiding any side reaction. And we know it's very important in pyrolysis, where the goal is to break down organic materials without unwanted chemical reactions. In the cathode production, so both nitrogen and oxygen are required. Nitrogen for inerting. Inerting when you have the co-precipitation of the three metals to obtain the pCAM. That does not work. Okay. So you see the co-precipitation phase where the nitrogen is required, also during the drying phase, and then for the NMC cathode, of course, you need the oxygen for the calcination process where you need some oxidation. The oxygen during the calcination aims at providing oxidative environment to oxidate the nickel, cobalt, and manganese. During the LFP process, it's I would say this is here nitrogen which is required. No need to oxidize because of course you need to calcinate the LFP, but LFP does not like so much oxygen, CO2, and moisture. So this is why the nitrogen is required for the process. Now, electrolyte phase. Electrolyte requires the nitrogen to ensure cleanliness and dryness of the containers. So electrolyte, as you know, is a key material, and it's the only one which is in form of liquid, which brings differences in terms of handling. It's a blend of unique conductive components, but that requires nitrogen once again for the cleaning and the drying of the containers. Last but not least, the cell production. So during the cell production, nitrogen here again is required both for safety and for the quality of the product. So safety as inerting to avoid any ignition of the flammable components, which are NMP and electrolyte, but also to ensure the quality of the process and contribute to get rid of the enemy, which is the moisture, during the vacuum drying phase and also during the enclosing, formation, and aging. So both safety, avoid that flammable products will get on fire, but also quality to make sure that the enemy, which is moisture, should be removed. It was mentioned previously, the helium leak test is also very important to ensure the quality of the product, and the helium test, the 2 helium tests are performed at the end of the process. So now what is the situation? You all know about it. Customers are having thousands of priorities. Gas represents less than 0.5% of the cost, and gas can be seen as a secondary product and not as a priority. But despite its tiny cost, industrial gases are essential to the reliability and the success of the ventures in the battery ecosystem. Considering industrial gases too late in the process can put at risk all the projects. And for this reason, industrial gases should not be neglected. So now how to ensure the competitiveness of the venture, how to be successful in the industrial gas approach. I would just provide 3 ingredients of what could be kind of pieces of advice. The first one being that you need to anticipate. If you consider the gas supply at the latest phase of your battery projects, it's going to be extremely difficult for your gas supplier to get competitiveness. Competitiveness requires time, and coming at the latest time is not the best way to optimize both process and TCO. So first piece of advice is really speak to us well in advance. The second one is the fact that it's important also to share gas techno concern and having techno discussions, because once again, industrial gases represent a very tiny cost, but in terms of efficiency and performance, it has a role and influence that I will not be able to detail today, but it has a certain influence on the performance especially I'm thinking of the cathode, I'm thinking of the vacuum drying and things like this. The third, I will go fast on that, and the third and last pieces of advice I would say is to develop the correct supply mode. I mean, you're not gonna reach your nominal production from day one. So for sure, why spending the money? Why oversizing your industrial gas supply mode if you're not gonna produce at 100% from day one? And this is where also it's important to speak to industrial gases companies in advance to really make sure that Air Liquide will support you in defining the ramp up from day one to final production. So thank you for your attention and have a nice end of show.